Hello friends, welcome to our YouTube channel. In this session, we will focus on how to uh, prepare a instrument process datasheet for the mechanical pressure reducing wall or the control wall, or we will look how the actual sizing sheet we will receive from the any of the manufacturer. And I will show you some format samples for your reference, or you will get the more idea about how to review the sizing sheet or the data sheet which we receive from the manufacturer or the designer for the uh, any of the control wall or the mechanical PRV sizing sheet of mechanical pressure reducing wall, or the same for the control wall. Okay, so we will first note down the what actually data we need to share with the vendors for the sizing of the control wall. First we need to mention the tag number of the control walls. Then we need to share the data like PNID number, that is for our the standard documentation format. Then we need to mention the size and rating. Okay, size and rating, flange rating, or the whatever may be the data. Then we to mention the service fluid. Okay, service fluid, whatever the service that may be your liquid or the gas we are using that wall for the application. Okay, then we need to mention the flow rate. Okay, flow rate in meter cube per hour or nm cube per hour for the gases, and meter cube per hour for the liquids. We need to mention the minimum, normal and the maximum flow rate. Okay, then the same for the we need to share same for the pressure. Okay, we need to mention the same for the pressure, like what would be the minimum maximum pressure rating in bar gauge. Okay, what would be the minimum, normal and maximum operating pressure. Okay, same we need to mention here. Okay, we have mentioned the flow rate, pressure. Then we need to mention the density of fluid, whatever it may be, viscosity of the fluid. Okay, then we need to mention the MOC of the walls and any remark. These are the basic things we need to provide for the any of the manufacturer for as a basic process data sheet or instrument process data sheet. You can sometimes we need to add some precise data like the operating pressure. Okay, operating pressure and the design pressure. Okay, sorry, operating temperature we have already mentioned operating temperature. And then we can sometimes we need to add the design pressure. Okay, sorry, design temperature and the pressure. So here for this example we will first look for the whatever the data we have mentioned here. We will just simply put it for the sample example, so you will get the more idea about this. Okay, so first we will mention tag numbers like CV R440. Then we need to mention PID numbers. You can mention as per your standard format of the nomenclature PID number 2. Then we need to mention the size and the rating. Okay, to mention size and rating, as we know, okay, here we will consider the size of 50 MB. Okay, so 50 MB, and the rating is of, for the pressure rating purpose, 150. Okay, then we need to mention the fluid. So here I'll mention the fluid as the water, or we have some examples of gas also. So here just we'll put it down the some data like the minimum flow rate. What would be the minimum flow rate required through the pressure reducing wall or the control wall? Here I'll mention minimum of 2500. That may be in range of 80-20%. So here I'll mention normal operating pressure or flow is 12 meter cube per hour. Here 2.5 meter cube, as we have mentioned the data in the meter cube, and max is the 15 meter cube requirement. Then pressure we have minimum 0.5 bar gauge. The normal operating pressure considering the pump or all these things, we have requirement 1.5. That requirement may be changes as per the your applications. And here we need to put the max shut off pressure if we are transferring that to the pump. Here I am just assuming some values for my reference. You can put it down as per your requirement. Okay, the density in kg per meter cube I have considered, and here we have viscosity 1 cp. Then operating temperature would be the room temperature, or I just assume that 35 degrees Celsius. Okay, degree Celsius. Here we need to mention the design temperature. Okay, what would be the range of design temperature? So normally we consider that wall is used for the any of application. So I'll just put minus 25 to 150 degrees Celsius. Okay, you can put it down the data as per the your requirements or your the process requirements. Then I need to put the data of whatever the material compatibility. If you have any acidic material or anything, then you need to go for the PFA line or the exotic material. Here is the only water, then we can consider simply SS316L or SS304. That may be as per your requirement. And here the remark column is for the purpose of the whether that control walls used in the line where insulation required. Then we need to put remark like extended handle walls or all these things. And here water, we don't need extended handle walls, or if any control wall or the PRV is for the IBR application purpose, then we just need to share that data as a IBR data or IBR wall karke. Okay, so hope you got the clarity about how to proceed for the instrument process data sheet for the inquiry purpose. Okay, here you got the idea. So quickly we will go further for the review of the what actually the data sheet looks like. Okay, so here you will see the example. Okay, first this is the example for the nitrogen application. We have one sizing sheet available with us for the gas application. Okay, nitrogen as a gas. We will get the item number, how many quantities we require, then here the tag number, then the process medium, that is the what would be the liquid or gas or whatever it may be, a liquid nitrogen or the acetic acid, xylene, toluene, or any of the materials. Then we need to mention the state of material, whether that is in the gas phase or liquid phase, or that may be a vapor liquid phase. Okay, dual phase. Then we'll get the data like they size, the vendor will size, manufacturer size the based on the data we have provided. Here are the three different cases. Any of the control wall or the any of the pressure reducing wall, they can size for the three different conditions. Here we have 60 nm cube per hours, 80 and 125 is the max. Oh, these are the three conditions like minimum, normal and the maximum. Okay, so for this condition we need to mention the or specify the inlet and outlet pressure which we miss in the sizing sheet. Okay, or the IPDS, that data needs to be given. Here for three different conditions the inlet pressure may vary, and we have requirement of fixed outlet pressure because we have that control wall or the maybe installed in the IBR pipeline or the uh, non-IBR pipelines. For this condition we have to keep the fixed outlet point which is less than 3.5 bar gauge, or that maybe this is the nitrogen that used for the blanketing purpose or the inertization purpose, so we need to limit that as per our set point. So here I have sized for the 0.6 bar gauge. Okay, then the inlet temperature may vary as this is the nitrogen with respect to the inlet pressure. Okay, here we have, we'll get the standard density of that material which is 1.25, then the isentropic exponent, or that is the gamma coefficient which you will get the standard for the sizing when you are going to size the control wall with reference to the any of the sizing calculations that may be using by hand calculation, Excel sheet, or the any simulation software. Okay, this is the real gas factor chart which we have to consider, and that is the standard for the different chemicals with respect to its properties. And we have here mentioned the viscosity that may be varies with respect to pressure and temperature. These are the inputs data whatever we have shared with the vendor. Okay, and based on that we will get the results on the sizing sheet or sizing basis of the sizing. Okay, first we will understood what is the case 1 or the minimum operating conditions. For these conditions we have calculated wall coefficient, or sometimes we call it as a CV. Okay, which is 2.26. Here we you can check that CV for the normal conditions or operating condition is 2.09, and for the case 3 we will get 3.07. That CV is the coefficient of discharge or coefficient of walls that varies with respect to our process conditions or the flow rate. If we reduce the flow rate, that CV value will get reduced. If we increase the pressure, our CV value will get the reduce. If we uh, reduce the pressure drop, that impacts on the sizing of the control wall or the CV sizing. Okay, and based on that CV sizing are this point reflects minimum required wall size. Okay, that actually the what would be the wall size, whether it is 1 inch, 2 inch or half inch, that reflects for these particular conditions. Okay, and it is unique for the different conditions based on the input parameters that we need to review. What is the actual calculated CV values? Then outlet velocity, what is the velocity for that pressure reducing wall or control wall? And this is the model vendor have selected. They have their standard model format, or they have their catalog. They put it our conditions into their sizing software or the sheet, and they generate the sizing results, and accordingly they select near about the values. If we require the uh, CV sizing something which is fit above the 1 inch holes and below the 2 inch hole, then they can go ahead with the 2 inch, which is the nearest of their fittest size. Okay, they considered some of the safety factor, delta P ratio, which is the actually the pressure drop across the wall or all these things. Okay, then you need to check the results or output data, what we actually get. This would be in this section we will get the final, what is the uh, results or actual parameters, actual sizing of our selected walls. This is the wall style, that may be a flanged, in this case it is a flanged wall, sometimes it may be a screwed or welded type. Okay, then actuator style, whether that may be a pressure or that varies with respect to pneumatic or with respect to our conditions. They select the series of their walls, that is the complete vendor's proprietary item. Then type is their catalog, or they have their unique catalog number and all these things. And we have required the control wall for the three different cases: minimum, normal, and the maximum. But vendor has for these conditions, you I think you understood now what is the calculated CV. For three different cases are calculated CVs that much. But vendor have their standard model which is of 2 inch near about that CV for these particular conditions. They have wall coefficient or the selected wall coefficient which is 37. Okay, sometimes we will get the query about the, we will check for the case 1, case 2 and case 3. For this maximum flow rate we have requirement of 125 nm cube per hour, and for this particular flow rate they have size the CV of 3.07. Okay, but we sometimes we need to calculate the what would be the actual flow rate in case of failure of the control wall or the PRV. Okay, so that needs to be calculated, or that is the quite higher than this 125 nm cube per hour, and that we needs to calculate with the use of that CV and the pressure conditions, inlet and the outlet pressure conditions. Okay, that is the actual flow rate in case of failure conditions. Or okay, then they have mentioned here the body material of the, what is the actual material of construction of that walls. Okay, and they select based on the R requirement. We need to mention that whether we need the CS material or SS 316, 304, 316L, or any of exotic material, or the lined walls like PFA, PTFE lined. Okay, that data we need to mention in the process data sheet for the inquiry phase, and they select based on that. Then wall size, which is actually we will sometimes we call it as 1 inch wall, 2 inch wall. That means the actual the wall size. Okay, that needs to be installed in the piping. Then the whether that is there is a noise reduction or what is the, okay, and we have mentioned the pressure rating of 50 NBO walls, 150 rating. That means they have selected the 150 class flange or the wall type for this particular operation. Then also we need to mention sometimes we have to communicate vendor that the control, in case of control wall, what would be the actual fail safe condition. Suppose in control wall the air failure or any of the component failure, that wall needs to be go to the fail safe condition or safe mode. So that in that condition we need to mention that fail safe condition, whether that is in fail safe condition that may needs to be open or closed. In vents or the vent application we need that wall is a fail safe condition. In the utility or the in steam, that needs to be a fail safe condition. In cooling water or fail safe open, so avoid the thermal expansion, that mm, in case of failure. Okay, then here pipe data, what is the pipe material, pipe steel pipe, whether that is the insulated or not. They have mentioned the pipe data which considered for the walls density of that. Okay, hope you got the somewhat idea about the what would be the actual the control wall or the mechanical PRV sizing sheet which we received from the vendor. This is for the gas application. In the next uh, uh, sheet, I will just explain you the for the vapor phase or the liquid phase. Okay, here we have the sizing sheet for the steam application purpose. Okay, as you know, the all the data remains same, like input parameters like flow rate for three different conditions: minimum, operating, and the maximum condition. Then the inlet pressure for three different conditions. As we have given three different conditions, the pressure, inlet pressure will be same for the each conditions apart from the others, and the are required pressure. Okay, required pressure, as this is the pressure reducing wall or pressure reducing station or control wall that needs to be control the outlet flow rate, or whether that needs to be control the outlet pressure. So in this case, for the steam, this is the non-IBR control wall. So here we require 3.3 bar gauge of outlet pressure, and the temperature of the steam for the different condition based on the temperature. Okay, density of steam here mentioned for three different condition, and as you aware about that, the what would be the actual calculated CV for three different conditions with the parameter. For this minimum case, we have required flow rate of 2000 kg per hour, and the pressure, inlet pressure is 7.8 bar gauge, and our required pressure is 3.3 bar gauge, because for this reduction purpose we have installed the mechanical PRV or the control wall. Okay, so with these conditions, our calculated CV calculated CV is directly, or it express as the opening. It is related to the opening of walls or the orifice size, you can say like this. Okay, which is required for this case is 21.2. For this case, our required CV is the 31.3, and for this 5000 kg per hour, calculated CV is 51.6. Okay, and the vendor has selected or shared the data for the what is the nearest uh, item or nearest wall standards or the wall type available with them for this particular condition. They have selected the CV, say 94 3-inch wall size. Okay, for our conditions to meet our requirements. Okay, so if you check the uh, flow rate, what would be the actual flow rate of this steam? Sometimes you will get the question like what would be the maximum flow rate across the control wall or the PRV in case of 100 maximum, or that means the 100% opening. So for this case, we need to calculate the maximum flow rate using the simple equation, that is the CV value here. And in one of the session, I have explained how to calculate the control wall sizing based on the uh, CV values or based on the flow rate and the inlet outlet pressures. So you will get the idea about how to size the control wall, and you can check the maximum flow rate using the reverse engineering of that same formula, and you can check it to our channel. You will get easily how to calculate the control wall sizing based on that. Okay, and here this is for the vapor phase. Okay, till now you got the idea about how to calculate or how it looks like the sizing sheet of the control wall for the gas, for the vapor phase, and I'll explain the same for the liquid phase also. If I just need to check whether that is available with me or not. I guess that is not available with me right now, so I'll just explain. Nothing will change for the liquid case also. In liquid case, you will get the process medium. Here is the what is the actual fluid for which we are going to use the control wall or the reducing wall. Okay, so you need to just put that data into the data sheet, like liquid, what is the acetic acid, xylene, toluene, benzene, or any of the solvents or any of the process material like the MDC, DMF, or what is the actual your material. Then you simply share the data of the state of medium or state of the condition. What is the actual flowing fluid state, whether that is liquid, gas, or dual phase or vapor phase. That's data needs to given to the manufacturer in the form of instrument process data sheet. And for this case you need to specify the same conditions like minimum, maximum, and the operating. For the three conditions you need to give the flow rate, what would be the minimum flow rate, what is the actual lowest flow rate which you needs to pass through that control wall. Okay, so that's needs to give one precise so that you can use that walls up to that much conditions, because if you have used that wall below that flow rate, then there may be a chances of some variations in the actual measurements. That may be instead of that walls pass 400 or 450, that wall passes 300 or 200. So you to get the precise data as per the operating conditions, you need to give the minimum and the maximum conditions or operating conditions precisely, so that to avoid any of the uh, confusion or any inappropriate data or the results during the actual operation in the plants. Okay, hope you got the idea. I don't know whether you got the complete idea or not, but you got some what about the what is the actual instrument process data sheet for the control wall, and how it looks like when it comes from the vendor to us for the review purpose or for the approval purpose, and what things needs to check prior to given approval to the manufacturer. Okay, still you have any doubts, you can drop me a message or you can connect me over the mail, which mail id I have specified in channel link. So you get the more clarity, more idea about the control walls or any topics which you have looked from our channel. Okay, for now, if you new to our channel, you can subscribe or like these videos to get the more related videos about the chemical process engineering, project management, or the instrumentation or the sizing. Okay, hope you will enjoy this session, and thank you for now. Bye bye.